This is section 6.6 from chapter 6 in Algebra 1, Structures and Method, Book 1. I like this section. I think this is a pretty cool section. I think that this, again, strengthens the foundation of fraction work, mixed expressions. It's a very interesting, neat way to deal with your fraction work. It really tests your knowledge. Converting to, this is an interesting way. So whoa, that's interesting also. So they do 3 plus 2/3, and then they turn this into thirds. So they do this, they show equivalency, and we go back to what we were doing in 6.5. We're going to multiply that by 3. This has to be a value of 1. It's the identity property. So we get 9. So 9/3 plus 2/3 equals 11/3. And 3 2/3 is equal to 11/3. That's the long way. I was always taught you do 3 times 3, which is 9, plus 2 is 11. That's the way that I'm always going to do it. The problem is when we get to negative numbers, students make a very, very common silly mistake. And we'll do that when we get to a negative number. Sorry, I had a little coffee with milk and chocolate. 8 times 2 is 16, plus 1 is 17/8. And here's our first negative. So if we saw this, this is the problem, is you have negative 3 plus 3/5. Unfortunately, a lot of students would do this. What's wrong with that? Well, that says that part is negative, but this part is positive. That's incorrect. It needs to be stated in this fact. Remember, numbers have two things. They have direction and distance. So distance and direction, the negative. So the direction is positive and negative, and the distance is the number. That's how far away from 0, either left or right. So students oftentimes, when they do this, they do 5 times negative 3 is negative 15, and then they do plus 3, and they make it negative 12. But it's not plus 3. It's 5 times 3 is 15. Plus 3 is 18, and then the direction is still negative. So negative 18/5 is the proper way to do this. 7 times 4 is 28, plus 5 is 33, so you have negative 33/7. You have 31/6. You have 31/5. You have 8, negative 11/4. 9 times 1 plus 2 is negative 11/9. And that's a good start. So we're going to make this 6 over 1 plus 1 over x. We're going to look at the denominators. We know that the common denominator would be x. So now we're going to write equivalencies of 6 over 1 equals 1 over x. We're going to multiply this by x over x. We get 6x. And 1 shouldn't change. So we get 6x plus 1 over x, because now we have like denominators. We can combine their numerators. Those are unlike terms, so we can't combine 6x and 1. Same thing, 2 over 1 plus 5 over a. We get 2a over a plus 5a. And I hope we're at this point where we don't have to show our work. Show work, maybe. And then you get 2a plus 5 over a. These should be relatively fast. 3 over 1 minus 2 over x. I don't mind you writing that statement. Then you get 3x over x minus 2 over x. which equals 3x minus 2 over x. But I got to believe if you're following along with me on these chapters, you should be pretty proficient. Well, I don't know what that was. You should be pretty proficient at this point. You should be able to roll through this quite quickly. And you should just be checking work. This is a good one. I don't mind this one. Over 1, 2 over a. So we get 5a squared over a minus 2a. Hopefully you see that. 5a over 1 equals what over a? We're going to multiply it by a. You get 5a squared. So 5a squared minus 2 all over a would be our answer. Same thing here. We have 6n over 1 minus 4 over n. Equivalent fraction would be 6n squared over n. Now we have like denominators. We're not going to look to simplify this just yet. That's not the difference of squares anyway. The 6 is not a perfect square. And we wouldn't factor out a 2. Well, actually, that would be interesting. Yeah, you might see that. 2 times n squared minus, 2 times the quantity 3n minus 2 over n. Maybe you might see that. Maybe. We'll write a maybe. Maybe that. Because we do want to see if we can cancel stuff. I like this. This is tricky. So 3y plus, that's going to be y squared over y. And now we write y squared plus 3 over y. We're always going to write our answer in standard form. 4 over 1 minus m over n. That's going to be 4n over n minus m over n. All right. So technically you get minus m plus 4n over n because you want m alphabetical order when standard form. I'd factor out the negative and write m minus 4n over n. I'd probably write it like that. I don't mind. I'm up for putting that negative outside. 2 over 1 plus x over y. That's going to be 2y over y plus x over y. We're going to do the x before the 2y over y. Standard form. Okay, 3 over 1 minus 2 over x plus 1. So the prime factorization, 1 would be 1. X plus 1 would be x plus 1, that quantity. So LCD, they have nothing in common, and these are the leftovers. That's the leftover. So my LCD is going to be x plus 1. So x plus 1 is going to be my common denominator. That's not going to change, and now we have to find an equivalency. So 3 over 1 equals what over x plus 1? Now this one is completely different from that. That is not the same. So we're going to have to multiply it by x plus 1. And so that becomes 3 times the quantity x plus 1. So 3 times the quantity x plus 1. Now we're going to have to simplify that. So now we're getting into some fun stuff. So we get 3 times the quantity x plus 1 minus 2 all over x plus 1. That becomes 3x plus 3 minus 2 over x plus 1. That's 3x plus 1 over x plus 1. And hopefully we'll have to factor those and something will cancel and we can simplify it. 7 over 1 plus y over y minus 2. So we get 7 times the quantity y minus 2 plus y over y minus 2. That side work, 7 over 1 equals what over y minus 2? We'd have to multiply it by y minus 2. So notice that we take our numerator and multiply by what it's missing. So you see it right there. And That's the work that I don't need to do. I don't have to show that work because I know that step already. And so I can just write it. I know where that statement's going. 8y minus 14 over y minus 2. We can factor out a 2. We get 4y minus 7 over y minus 2 is how I'd like to see it. All right, x over x plus 3 minus 4 over 1. You get x minus 4 times the quantity x plus 3 over x plus 3, which gives us x minus 4x minus 12 over x plus 3, which simplifies to negative 3x minus 12 over x plus 3. Let's factor out a negative 3. We get x plus 4 over x plus 3. I like that. If you want to throw the negative out there, you can throw it out. That's fine. 3x over 1 plus x over x minus 1. This one's a little bit more. 3x times the quantity x minus 1 plus x over x minus 1. 3x squared minus 3x plus x over x minus 1. 3x squared minus 2x over x minus 1. Let's factor out the x. 3x minus 2 over x minus 1. That's a good one. 5x over 1 minus x over x plus 2. Common denominator is going to be x plus 2, so we have 5x times x plus 2 minus x. 5x squared plus 10x minus x over x plus 2. 5x squared plus 9x over x plus 2. Factor out an x. 5x plus 9 over x plus 2. 3y over 1 plus y over y minus 2. Common denominator is y minus 2. 3y times y minus 2 plus y. And we see the similarities to these. The repetition isn't a problem. It's actually good for you to start seeing the patterns. 3y squared minus 5y over y minus 2. You want to be able to recognize what you need to do in each problem. That recognition through repetition provides you a stable foundation in, this is a good one. So if 2n, let's do this. If 2n plus 3 is my common denominator, what is that as a value of 1? Yeah, it's 2n plus 3 over 2n plus 3. That's a good one. I like that. 2n plus 2n plus 3 over 2n plus 3. 4n plus 3 over 2n plus 3. Nothing cancels. I know a lot of students would want to cancel the 3's, cancel the 4n and 2n. You can't do that because they are adding. We can only cancel when they're multiplying. But that repetition really helps you with speed, accuracy. The more problems, you can recognize the trick ones because you've done it so many times that you know what the trick ones look like, you know what the regular ones are, and you know the difficult ones, and you know the pitfalls of the difficult ones. Now, so we're going to see, and that can't be factored. I already know that. But we'll do a times c. So that's 2 times 1 is 2. Factors of 2 are 1 and 2. Signs are different. Bigger is positive. So that's not my middle. So that's unfactorable. Okay, so that is as simplified as you can get. 3 over 1 over a minus 3, 2a minus 3 over 2a plus 1. We have 3a times the quantity 2a plus 1 plus a minus 3 all over 2a plus 1. That's 6a squared plus 3a plus a minus 3 all over 2a plus 1. 6a squared plus 4a minus 3 all over 2a plus 1. That's 18. 6 times 3 is 18. 1 and 18. 2 and 9. 3 and 6. Signs are different. And the bigger is positive, but none equal 4. 7, 17. So, and there's no common factor amongst the three of them. Oh, okay. This is going to be, this one will be interesting. So we get 3a squared times 2a plus 3 minus the quantity a plus 1 all over 2a plus 3. Lots of little nuances here. We got to distribute that to both of those terms because it's minus. So this is a good one. This is 6a cubed plus 9a squared minus a plus 1 all over 2a plus 3. Now, none of those have a common factor. And now I'm going to test and see factor by grouping. When we have 4 terms, I always look factor by grouping. So we have 6a cubed plus 9a squared minus a plus 1, and we'll group those and group those. So I can factor out a 3a squared, and that gives me 2a plus 3. I can factor out a negative 1, and that gives me a plus 1. Notice these are not the same. They must be the same. So this is unfactorable. This is my final answer. I could move them around, but nothing's going to get there. So you cannot factor by grouping on that one. Tricky one, but wasn't factorable. Minus 2x plus 1 over x plus 1. We get x squared times the quantity x plus 1 minus the quantity 2x plus 1 over x plus 1. You get x cubed plus x squared minus 2x plus 1 also isn't going to factor. I already know it's not going to factor because if I take out the negative, we're never going to get 2x minus 1 from those other 2 terms. So that's factored. Oh, come on. Hopefully it'll factor. So, can you see what the common factor is? Do you know that that's what the common denominator is? Because think of our denominators. It's 1, it is x, and it is x minus 1. So the 1, the x, these are all, so they have nothing in common. And so these are the leftovers. And notice what my denominator is. X times the quantity x minus 1. So what is this missing? You take the numerator, x, and you multiply by what it's missing. What is this missing from this? It's missing an x. So we do x times x. What's this missing? So this is its numerator. Ooh, this is kind of tricky. That's what it's missing from the denominator. I have to multiply it by its numerator. And then you have, this is definitely a lot of work on the first one. And then you have negative 2 times, what is it missing? It's missing everything. So you get x squared plus, now we're going to do this. This is multiplying binomials, binomial squares. That's x squared minus 2x plus 1. And then that's negative 2x times this, which is negative 2x squared plus 2x all over. I'm not going to distribute that because I'm hoping that I might be able to factor that numerator, and I can't cancel things being added and subtracted. So these x squares actually cancel. The negative 2x and positive 2x cancel, and we're just left with 1 over x times the quantity x minus 1. All that work for that. Okay, it's fun. It's a good one. X over 1. Now they go back to, they like absolutely kicked us in the teeth on that first one. And now they have a relatively benign second one. It's okay, we'll take it. X squared minus 2x plus 2x plus 1. That's too bad that's not a minus 1. Too bad that's not a minus 1, so we could factor it. So x squared plus 1 over x minus 2. If it was a minus 1, we'd be able to factor it, difference of squares. Our common denominator is going to be x plus 1. So it's 3 plus x plus, minus 1 times the quantity x plus 1. We get 3 plus x minus 1 over x plus 1. And that's going to give us 2 over x plus 1. Nice and easy, elegant, clean. So notice different. So my common denominator is going to be x plus 3, x minus 3. This is my numerator times what it's missing, plus my numerator times what it's missing, times my numerator times what it's missing. And I got to do that multiplication. Well, actually, I don't have to. That's okay. We're going to get x squared minus 3x plus x squared plus 3x minus 3 times, that's conjugates, all over x plus 3, x minus 3. We can simplify some of it. That's 2x squared. The 3x and the negative 3x cancel. Let's distribute that. That's plus 27 over x plus 3, x minus 3. That's negative x squared plus 27 over x plus 3, x minus 3. And let's factor out that middle, that negative. You get x squared minus 27, x plus 3, x minus 3. Not a perfect square. All right, that's not a problem, not a problem. X plus 1 is going to be my denominator, minus 4 minus the quantity 3x minus 1. So where they're trying to trick you, or at least test you, is with that negative. Do you remember to distribute that negative to each of those and write it properly? X squared plus x minus 4 minus 3x plus 1 all over x plus 1. X squared minus 2x minus 3, x plus 1. Factors of 3, 1 subtract equal 2. Yes. You get x minus 3, x plus 1. Finally! We finally got something to cancel. Let's go! Finally. All right, now we're cooking with gas, as Mr. Mac loves to say. So this is x minus 1 times x minus 1 plus 3 times x plus 2 times x minus 1. That's the perfect notation. That's what a high school honors, high school algebra teacher is going to want to see. So this is the difference. This is a binomial square. So you get x squared minus 2x plus 1 plus 3x. And that's going to be plus 2x squared. We'll just multiply those two and then distribute. 2x squared minus 2x all over x times x minus 1. 3x squared minus x plus 1. That is not factorable. Let's make sure I did it correctly. That's x minus x, yeah. Plus 1. That's not factorable. That's too bad. We have a minus 1, a plus 1. This is 2a times a minus 1. That's 3 times a plus 1. That's negative 1 times the quantity a minus 1, a plus 1, because it's missing both things over 1. It's missing both of those things. That's the reasoning behind it, just in case you didn't know. 2a squared minus 2a plus 3a plus 3 minus 1 times the quantity a squared minus 1 all over a minus 1, a plus 1. 2a squared plus a plus 3 minus a squared plus 1. So I simplified and then distributed all over a minus 1, a plus 1. Nope, that's a squared plus a plus 4. That's a very weird one. Can't say I've ever seen that, and that is unfactorable. Factors of 4 when added are never going to equal 1. Last one looks relatively easy. X plus 3 minus x minus 1. 2x plus 6 minus x minus 1 all over x plus 3. You get x plus 5 over x plus 3. Super easy. Nothing. Oh, okay, here we go. X minus 1, x plus 1. You have 3x times x plus 1 plus 2 times x minus 1 plus x minus 1, x plus 1. 3x squared plus 3x plus 2x minus 2 plus, and we know what that's going to be. That's going to be x squared minus 1 all over x minus 1, x plus 1. It's interesting on why they decided which ones were going to cancel and which one weren't. That's 5x, and that's minus 3 all over x minus 1, x plus 1. Factors of 12 when subtracted. 1 and 12, 2 and 6, 3 and 4. That's no middle. Does not equal 5. Boom. All right. Only one of them canceled. That's a bit of a bummer. Bit of a bummer, if you ask me. 6-6. What was the title of this? 6-6, and this is Mixed Expressions.